This is a theoretically perfect player. It never makes a mistake, and it never loses. The best you can hope to do is tie. Through a process that I'll explain later, the machine considers over 500,000 positions before it makes its first move. Tic-tac-toe is known as a solved game. That means that there's always an optimal move for each player. I'm going to show you how to never lose when you're playing O in tic-tac-toe. First, you need to go in the center. If you go anywhere else, then X has a guaranteed win. Then you must go in an edge, and that will force a draw. Of course, it didn't always play so well. It took some time to get the algorithm working properly. These are some of the earlier revisions of the software. One of the very difficult but often overlooked pieces of this puzzle was the display and drawing everything in the correct place, registering touches appropriately and then acting on them. Here it shows all the possible moves that it simulates after each one. So after the first one, there's 549,000, then 8,200, 245, and then 10. Here is an example of how this program works. This is a late game example where there's 4 possible moves. It will pretend that it took each of these 4 possible moves, and then it will switch its frame of reference to the other player, and then do the exact same thing, and consider all the possible moves that are left, and then switch, and then back and forth until there is a tie, a win, or a loss. Maybe you can already see how this kind of recursive program adds to a lot of simulations. Once a game ends, it's assigned a score of -1 if it lost, 0 for a tie, and 1 if it won. And that score gets added with all the scores above it to produce a final score for that entire branch of simulated games. And all it does is pick the branch with the highest total score, which would lead to the best outcomes.